Is the Chinese Navy testing the planet's most powerful helical weapon? The Chinese Navy is reportedly testing the most powerful coil gun on the planet, a type of electromagnetically powered weapon capable of launching projectiles with very high velocity and precision. In a test firing revealed to the public for the first time, the electromagnetic launcher accelerated a 124 kg projectile to a speed of 700 km per hour in less than 0.05 seconds, according to the scientists involved in the project. It is the heaviest known projectile used in an experiment with a coil gun. While the weapon's exact dimensions and maximum range remain classified, a projectile moving at such speeds could hit a target several kilometers away. Coil guns are also known as Gauss guns or magnetic accelerators. The weapon consists of a series of coils arranged along the barrel of the weapon, each constituting a stage. Each coil is fired one after the other to create a magnetic field that can levitate and propel a projectile forward. The projectile usually remains suspended in the center of the coil during firing, helping to keep it in a straight line and preventing it from hitting the barrel wall. It can be fired repeatedly and quickly without wearing out components. Coil cannons could revolutionize wars, allowing for faster, more accurate, and more devastating strikes against enemy targets. They could also launch missiles or send satellites into space. Technology has been around for decades, but materials science and electronics challenges have made it difficult to build large, powerful models. One of the closest competitors to the Chinese coil gun, a 120mm caliber coil electromagnetic mortar test device from the U.S. Sandia National Laboratories, can fire an 18 kg shell. It is one of the largest such devices ever built. According to a study published in January by Israeli scientists in the journal Scientific Reports, other systems around the world often fire projectiles weighing a few grams and a few millimeters in diameter. The larger a coil gun, the greater its ability to fire projectiles similar to those fired by traditional artillery. A standard 155mm artillery shell used by the U.S. military weighs about 43 kilograms, while Italy's Indigo air defense missile weighs 120 kilograms. According to the Chinese team led by Professor Guan Xiaoqin of the Naval Engineering University, the coil gun has a number of advantages over traditional artillery, such as higher launch speed, lower launch costs, and shorter preparation time. It has the potential to achieve revolutionary advances in speed, range, power, precision, safety, flexibility, and reliability. Guan and colleagues write in a paper published this month in the journal Transactions of China Electrotechnical Society. It is widely applicable in fields such as weapon systems, near-Earth satellites, and high-speed missile launches, they add. The 30-stage coil gun is still being tested, and it is unclear when it will be deployed in the field. However, the Chinese military has invested heavily in this technology recently. The Naval Engineering University has overcome several difficulties in building a large coil cannon, Ma Weiming, chief scientist for the Chinese military's electromagnetic launch program, said in a paper published in June. Ma explained that challenges included designing and manufacturing large-gauge, high magnetic density coils and compact pulsed power technology. He added that China is currently developing an even more powerful coil gun, capable of launching a projectile at a speed of 3,600 km per hour, which could raise the weapon's deadly range to more than 100 km. The rapid development of coil guns in China was partly due to a breakthrough in sensor technology, according to Guan's team. Coil guns generate a strong magnetic field when fired, which can interfere with electronic devices and sensors, so research on electromagnetic launchers often requires measuring the flight behavior of the projectile by external means. However, Guan's team devised a new smart projectile equipped with sensors that are shielded from electromagnetic interference by special materials, allowing them to collect high-quality data on the projectile's flight behavior. This precise data from internal sensors can help scientists improve the effectiveness and stability of coil guns. Maintaining the suspension of the projectile in the center of the coil during launch can be challenging, as any deviation from the center can cause the projectile to hit the barrel wall and affect its trajectory. Onboard sensors helped Chinese scientists spot problems that the computer model missed. According to the team, at the start of the launch, the test projectile was at the bottom of the drive coil due to gravity. When the pulsed current was turned on, the electromagnetic force pushed the test projectile. Since the electromagnetic force was greatest at the tail of the projectile, it caused the projectile to tilt and collide with the inner wall of the drive coil, causing the acceleration data to fluctuate, they said. As the test projectile went through the later stages, it began to wobble because the impulse current was fired at the wrong time. Discoveries like this can help scientists improve the performance of coil guns. For example, wobble can be reduced by adjusting the tripping time of the impulse current through the coils. Thanks for watching.